Every single minute, we're sending something like 200 million emails, making almost 6 million Google searches. It's just this constant, massive storm of digital information. A total mass of raw data, right? So how in the world do you find the actual signal in all of that noise? Well, that's what we're going to get into. This is all about data engineering and how it brings order to all that chaos. So here's the big question. The central problem, really. Companies today are practically drowning in data. They have all these raw ingredients, but they're really struggling to turn them into that gourmet meal of actual insights. They know the answers are buried in there somewhere, but honestly, the path from just having a bunch of raw data to getting real value out of it, well, it's a long and winding one, and it is so easy to get lost. And this is exactly why it's so hard. Look at this. Data isn't just born clean and organized in some neat little package. Nope. It is coming at you from everywhere. You've got your main business data in transactional databases, sure, but then there's real-time events from your website, social media feeds, server logs, even just simple spreadsheets floating around. Every single one of these lives in its own little world, speaking its own language. It's chaos. At the end of the day, it all comes back to one thing: the business. The whole reason we even bother collecting all this data is to get clear, reliable answers to important questions. Companies want to understand their customers better so they can give them better service. They want to make their operations more efficient. And yeah, of course, they want to increase profit. Good data gives them the power to make decisions based on cold, hard facts, not just gut feelings or assumptions.
Okay, so this is where our hero, the data engineer, steps onto the scene. I want you to think of them as a master plumber, but for data. Their job is to build this incredibly robust pipeline that connects all those separate, chaotic sources. They control the flow, clean things up along the way, and make absolutely sure that what comes out the other end is clean, reliable, and totally ready to use. Now, the classic foundational method for this is a process called ETL. It's kind of like a three-step dance. First, you extract the data, basically pulling it from all those different systems. Then comes the most important part. You transform it. This is where you clean it up, get rid of errors, and apply all your business rules. And finally, you load it into a central system, usually a data warehouse, which is a special kind of database built just for analysis. Extract, transform, load. ETL.
All right, let's zoom in on that T, the transformation step, because this, my friends, is where the real magic happens. This is the process of taking all those raw, messy, sometimes weirdly formatted ingredients and turning them into a polished, consistent, gourmet dataset that's actually ready for someone to analyze.
So to really get why transformation is so important, you've got to understand that there are two fundamentally different kinds of systems out there. On one hand, you've got your OLTP systems. That stands for Online Transactional Processing. These are the engines that run the business day to day. Think about the cash register system that processes your credit card when you buy a coffee. It needs to be fast for that one transaction. On the other hand, you have OLAP systems, Online Analytical Processing. These are built to analyze the business. They answer the big questions like, what were our total coffee sales in every state for the last quarter? And the reason these two systems are so different comes down to how they physically store the data. It's a huge deal. Your OLTP systems use what's called row-based storage. So if you need a customer's entire profile, name, address, phone number, it grabs that whole row in one shot, super efficient. But for OLAP, if you just want to add up the sales amount from 1 billion transactions, reading every single piece of customer data would be a colossal waste of time. So it uses column-based storage. It just grabs that one sales column and adds it up. It makes analytics lightning fast. Okay, so having clean, transformed data is great, but it's still not quite enough. You can have a perfect pile of bricks, but you still need a blueprint to build a house, right? You need to organize the data in a way that actually makes sense to the people who are going to use it. And this is where data modeling comes in. It's all about designing a structure that lets analysts and business users intuitively ask and answer their own questions.
The most popular technique for this, by far, is called dimensional modeling. Don't let the name scare you. It's basically just a design philosophy, a set of best practices for organizing data around your business processes. And the goal isn't just about making queries run fast. That's part of it. But it's also about making the data super accessible and easy for a non-technical business user to understand and explore.
And the absolute classic example of a dimensional model is the star schema. And you know what? It's really beautiful in its simplicity. Right at the center of the star, you have what's called a fact table. This is where your numbers live, the core metrics, like sales amount or quantity sold. Then, surrounding it, you have your dimension tables. These provide all the context. They answer the questions: who was the customer? What product did they buy? When did it happen? Where? This structure makes asking really complex business questions surprisingly simple.
Now, of course, the world of data never stands still. Things are always evolving. And the latest major innovation is something called the Lakehouse architecture. The big idea here is to try and combine the best of both worlds: the raw, flexible, cheap storage of a data lake with the powerful, structured, fast-querying features of a data warehouse.
And this new architecture has basically flipped that classic pipeline on its head. Instead of ETL, now we talk about ELT. With the absolutely massive power of modern cloud computing, we can just extract the data and immediately load it into the lakehouse in its original raw form. The transformation happens later, inside the platform itself. This is so much more flexible because you get to keep the original raw data forever and can decide to transform it in different ways for different needs later on.
So, a really common best practice for organizing data in one of these modern lakehouses is the Medallion Architecture. It's a simple but brilliant three-tiered approach. You have a bronze layer, which is your landing zone, just a direct, untouched copy of the raw source data. Then, data moves to the silver layer, where it gets cleaned up, validated, and enriched. And finally, you have the gold layer. This is the polished, pristine, business-ready data, often aggregated and modeled into those nice star schemas we just talked about.
And after that entire journey, this is the payoff. This is what it's all for. You've taken that total chaos of messy, disconnected sources, and you've meticulously refined it into a single source of truth. This beautiful gold data is now ready to power everything, from powerful interactive dashboards and accurate business reports, all the way to training the next generation of predictive AI models.
So if there's one thing to take away from all of this, it's this. When data engineering is done really, really well, it becomes completely invisible to the person using the data. All the complex pipelines, the transformations, the modeling, it all just fades into the background. It just works, seamlessly turning questions into answers, curiosity into clarity, and raw data into confident, smart decisions.